Welcome back. Hope you all are doing good. My name is Adil Khan, chemistry teacher in Base Education Services Private Limited. So let's start today's session again. It is bridge course for standard 11th or the first PUC. So in the last session, third session, I have given few questions and I have asked you to calculate the molecular mass of these molecules, which I have given you. Hope you have done. In the previous session, there was one thing I did intentionally so that you can find it out or not. Let's see how many of you have got it. So when I come to that, I will discuss. So you need to find out molecular mass of benzene first. So benzene, 6 carbon and your 6 hydrogen is there. So it is coming at around 78. So 6 into 12 plus 6 into 1, you need to add that. The nitric acid, nitrogen is there, oxygen and hydrogen is there. So when you add everything, you will get 63 as the molecular mass. Then comes your glucose, a very standard molecule which we see often. So this is close to 180. And this I told you as chloroform, but I give you as methyl chloride. So that was the trap which I wanted you to find out. So chloroform is this. First one is methyl chloride, second one is chloroform. You would have seen in your 10th standard that how chloroform looks in lab. If you haven't, when you come to us, we will show you in lab. It's an important solvent for various reactions which we use. So methyl chloride, when you find out, so there is 1 carbon, 1 chlorine and your 3 hydrogen. So when you calculate accordingly, it comes 50.5 because chlorine is 35.5 with respect to its mass. Then chloroform, how much it comes? It is 119.5. And at last, Na2CO3.10H2O, that is sodium carbonate decahydrate. So this is 286. And this is also known as your washing soda, which we will do in standard 11th or first PUC in the S block chapter much in detail. Got it? So this was your homework. If you have got all 5 on 5 right, then pat yourself. You have done a good job. Otherwise, if you did some mistake, you can go back to the lecture, see the lecture, and again try to solve it. Good. So starting today's lecture, that is your session number 4 for bridge course. When you see this, what comes in your mind? So you have a lemon, you have a soap, and you have a white color powder something. So yes, that's right. So the thing which comes in your mind is lemon. Lemon contains citric acid. So this is acid. And this is soaps. Soaps are basically basic. It contains base. That's right. And this is nothing but your table salt, which you eat every day in your food. That is salt. So the topic of the day is acid, bases, and salt. One important question comes in mind that why we study acid, bases, and salt. What is the use of it? So if it doesn't have any significant relevance, why we study? Answer is, it has a very high significant relevance in our day-to-day life, because most of the food what we eat and most of the things what we use, either it is either of them. For example, milk when you drink, curd when you eat, it will be having lactic acid in it. You eat any food, it will get digested because in your stomach, gastric juice is there. That is nothing but your HCl, hydrochloric acid, that too in concentrated form. One trivia you would have seen that the stomach gastric juice, that is HCl, has even the capacity to melt small amount of metal, whatever goes inside. So that is a trivia what most of the website quote. Then you have tartaric acid in tamarind. You eat apple and grape, you have malic acid there. And tomatoes, oxalic acid is there. Fertilizers, most of them are acidic in nature. Bases, your toothpaste is base. So you use that. Your soaps are there. Salt, the NaCl, what you eat every day. So every day to day activity, you will encounter either of this. That's why we do this chapter, and that is the importance of this chapter. I hope that part is clear. Okay. Now let's start what is acid, basis, and salt. First, let's remove this. Just a second. So we need to remove this. So let it keep it up. Let it keep it up. And this also we can pull it up, no problem. Okay now. So let's discuss about acid, basis, and salt now, much in depth. Not much because you will do when you come back to us. So the slight extra will do it. Now, session 4, acid, basis, and salt. So acid and basis are the most familiar of all chemical compound. You are studying from your 6th, 7th standard onwards. For example, vinegar is there in the acetic acid, which you use in your noodles or the Chinese food. And citric acid in lemon, like oranges, your lemon and all. And other citrus fruit, tartaric acid in tamarind. Magnesium hydroxide is an antacid. Antacid means whenever you eat too much, for example, you had some extra amount of puliogre today, then or biryani today, you definitely have some acidity because you are used to eat a proper size of meal, you consume extra. In order to get relaxed, you drink Eno or you Dizene or you take Gelusil. They all are antacid. So it give relief from acidity what you have in your stomach. Ammonia is used in the household thing, which helps in cleaning of various apparatus, utensils, and even help in cleaning the blockage in the pipes and all. So they are the basis and acid which is used in our day-to-day life. Classical concept of acid and basis. Now I'm not going into the real concept which we will be doing for you in the chapter thermodynamics. So classical concept, old concept, this is on the basis of their taste and the physical appearance and the touch and all. So earlier, the classification of acid and basis was based on the characteristic property possessed by each of them, what character they have. Now, one myth is there in most of our mind that acid is bad. Acid can cause corrosion. You see various things that sometimes someone touch acid, the hand will be corroded and all, and you would see in news also various times some accident happened due to acid. But acid is not always corroding in nature. It is not corrosive in nature always. For example, lemon you eat, so that is not corroding yours or skin or your intestine. Tartaric acid also comes in the same category. Lactic acid, which is incurred in the same category. There are a class of an acid which is highly corrosive, but other classes are normal, we can use in our day-to-day life. So that myth, you remove it at this point of time. Coming to acids, so what is an acid basically? So acid, for example, when you take HCl as gas, so this is known as hydrogen chloride gas. Now this is not an acid, okay? This is hydrogen chloride gas. The moment you add into water, you can write this as HCl aqueous. Now this HCl aqueous act an acid. Now when you add this into water, it's split as H plus and Cl minus. This H plus is known as proton, and this is responsible for acidic nature of HCl, or this only give rise to acids. So acid is a substance in aqueous solution. It break into H plus. We will see that later also. But let's see some characteristics of it. The first one is the acid is sour in taste. The moment you consume acid, it is sour in taste. Now, you know how to, which organ is help in detecting sour and all. So this is your tongue. Basically, the back portion of the tongue, this is responsible for your bitter taste. The front portion of the tongue is responsible for sweet taste. Aldehyde and ketones, which you will see later in organic, they have the sweet stuff. And this portion, these two portions, they are responsible for sourness. And these two portions are responsible for saltiness, salty taste. So your acid is recognized by this part of your tongue, whatever you have. obviously. So it has a sour taste, one thing. Now, why acid are sour? This is an important question which arises in our mind. It is sour because just now I told you that to be an acid, there must be an H plus ion. Okay. Now this H plus ion, if it is in more in amount, it will trigger the SAR receptor on our tongue. On our tongue, there are various type of receptors. Receptors means which react to something, which receive and react. So it will activate or trigger the SAR receptor on our tongue. That's why we will get the sour taste. Same thing goes with the bases also. Next is acid turns litmus blue. Now, generally we get confused, so I teach my kids like this. Whenever you see, suppose I hit my hand somewhere or my leg keep on frequently hitting benches and all. So we tell baap re, chot lag gaya, that type of thing. So baap re baap. I'm giving you a cheat code to remember this. And opposite of this, you can even call it as are baap re. So baap re baap means what? Basic red to blue. Basic red to blue, that is baap re baap. And are baap re means acid blue to red. Okay? Basic red to blue, baap re baap, and are baap re acid blue to red. That's why acid turn litmus red color, blue to red color. Now, what is litmus? Litmus basically comes as a paper. It is a litmus paper, which is a sensitive material which changes its color with respect to H plus and OH minus ion. And how to produce litmus? It is produced through a dye which is obtained from lichens. Lichens is a type of a fungi which is present around us. Basically, they are present in water. So that dye is extracted, and some book also write that litmus is produced from wood cellulose. So you can refer both of that. Okay. So baap re baap and are baap re. Please remember this. You will never forget the color of litmus. Third, acid react with active metal like sodium, magnesium to liberate hydrogen gas, obviously. So what do you mean by active metal? There are few metal like gold, silver, platinum. They don't react with acid. That's why they are very costly. You take gold and drop into HCl, it do not react. But when you take sodium, it reacts. Aqua regia is different thing. Don't get confused. Aqua regia can make silver and gold react. For example, when I take sodium and I make it react with hydrochloric acid aqueous, aqueous means it is in water. So what we see that we get salt, that is sodium chloride, and simultaneously we get hydrogen. And hydrogen exists as H2 on Earth's surface. It exists as H only on the sun. High temperature is required. So balancing is needed to 2 sodium, 2 NaCl, and 2 this, you will get this. So when you treat any acid with an active metal, you will get hydrogen gas and salt. Basically, mineral acid must be not organic every time. This is a mineral acid not having carbon in it. Same time, if I use magnesium and I treat with the kings of acid, that is H2SO4, again, it must be in the aqueous form. What I get, magnesium is Mg2 plus and sulfate is SO4 2 minus, and 2 hydrogen will come out. It is balanced. So that is the third thing, that when you take an acid, drop a metal, active metal, they will give salt and hydrogen gas. That's it. Next is fourth one, acids react with carbonate and bicarbonate to give carbon dioxide gas. This is again a new concept. Suppose you take sodium carbonate and you also take sodium hydrogen carbonate, that is sodium bicarbonate. And when you treat this with acid, suppose I treat this with HCl and I treat this with HCl. So in the first case, what I get NaCl and I get your hydrogen, water. With that, you get carbon dioxide gas also. And here, what you get, again, you get NaCl and you get water and you get carbon dioxide gas again. So balancing is required. You need to balance it. I hope this is balanced. 2 sodium, 2 chlorine, 2 NaCl, H2O, 2 hydrogen, oxygen is 3 oxygen, 1 carbon, balanced. Sodium, hydrogen, carbonate, so 2 NaCl again. So here you will write 2, so this is 2 NaCl and carbon is 2 2 oxygen 6, so 4 here and 2 here 6. So remember that whenever an acid reacts with a carbonate which is having CO3 2 minus, so carbonate is CO3 2 minus, and bicarbonate is when you add hydrogen, the minus charge will become less, it will be 1 minus. Then it will be giving you salt, water, and carbon dioxide, which you are learning from your lower classes. And the last point, when you take an acid I represent as A bar, and when you take basis, I represent as B bar. They react to give salt and water. So salt is a neutral entity, which I will tell you later, or neutral substance. So it neutralizes base. Neutralizes means the effect get balance. If 10 positive, 10 negative, it is 0. If 5 positive, 5 negative, it is 0, that type of thing. We will see that in neutralization reaction in the coming slides. Moving to the next, similar to acid characteristic, we will be doing base characteristic. So basically a base is a substance in aqueous solution. It has these many characteristics. They have a bitter taste, just like acid H plus trigger the SAR receptor, OH minus will trigger the your bitter receptor. So for example, NaOH, when you take as solid, and it is a solid, it's like a tablet. The moment you add into water, it become Na plus and OH minus aqueous. So this is responsible for the basic character of base. And you know that soluble bases are also known as alkali. So don't get confused between acid, bases, and alkali. Soluble bases are alkali, okay? And it is soapy in touch. The question arises why it is soapy in touch. Our hand has fat and it has your fatty acids, both oil and fatty acid. So the moment base comes and get in contact with our fingers, that fatty acid and oil, whatever is there, it will be dissolved in your bases. Due to that, the friction is lost. That's why that slippery nature is there. So generally our outer part of body, whether hand you take or feet you take or face you take, they have fatty acid or oil, or you can tell and oil. So when the base come in contact to that part of the skin, the base will dissolve this fatty acid and oil. Due to that, the friction is lost. Due to the loss of the friction, the slipperiness will be there, experienced by us. Third is bases turn red litmus blue, that is Bap Re Bap Wala concept. The explanation remains same. The OH minus ion, what is there? That OH minus ion will react with the dye on the litmus paper and change the color accordingly. And if acid can neutralize base, neutralize means bring down its effect, then bases can also neutralize acid. So it neutralizes acid. So this was the very trivial concept about acid and bases, which you are doing from your younger classes, lower classes. Now, in standard 11th, we will teach you 3 different concepts of acid and base. They are Arrhenius concept, Lewis concept, and Bronsted and Lowry concept. At this point of time in this session, I will discuss to some extent Arrhenius concept. Those 2 you will be doing in the classroom. Now, one of the important concept of acid and bases is Arrhenius concept. It was given by the Swedish chemist Savet Arrhenius, and he has given this at around 1887. This concept was given by him. And what he said that when you take acid and dissolve into water, it must produce or furnish H plus ion. When you take base, acid is A bar and basis is B bar. When you take basis and add into water, it must generate OH minus ion. So H plus is proton and OH minus is your hydroxyl ion. Okay. So what he said, that acidic behavior and the presence of hydrogen in the compound, he also introduced the concept of dissociation of the compound. Dissociation means breaking. For example, NaOH is a solid. It is ionic. Sorry, in this form, it is intact. There is no breakage, there is no dissociation or ionization seen. The moment you add into water, it forms aqueous, it forms Na plus and OH minus. So this is known as dissociation. Dissociation means splitting into ions. Ions means negative and positive, which we'll see now. So according to Arrhenius, an acid is a substance which dissociate or break. Break doesn't mean that it break into fragment. Split into ions. Dissociate into aqueous solution as hydrogen ion. So it is talking about H plus and Cl minus, or you take H2SO4. H2SO4 is made up of 2H plus and it is made up of SO4 2 minus. Okay. Good. Next is, for example, when I take this acid like HCl, nitric acid, sulfuric acid, this is acetic acid, this is an organic acid. These three are mineral acid because carbon is not present there. So they dissociate into H plus ion, which is also known as proton in water. The thing which I have shown you before, it is exactly here. So proton and chloride ion, proton and nitrate ion, high proton and sulfate ion, proton and acetate ion. The last one is called it as acetate ion from acetic acid. Similarly, basis is a substance which dissociate or splits into hydroxide ion in water. So OH minus, for example, NaOH, this is NaOH, this is known as caustic soda. KOH, it is potash, ammonium hydroxide, calcium hydroxide. You know, it is inside water, it is known as what? That you have to tell me. Lime something it is known as? Quick lime? So it dissociate to give OH minus in water. So sodium ion and hydroxide ion, potassium ion and hydroxide ion. So that's the concept. Just remember that. I am giving you a nutshell of this. So according to Arrhenius, if you have an acid in water, it must generate H plus. According to Arrhenius, if there is a base in water, it must generate OH minus. That's the end of the day. It has a lot of demerits that we will discuss later. Not this is the right time. I'll tell you why. What is the demerit? For example, ammonia is a base, but it is not having OH. How to prove that? So that we will discuss later, not at this point of time. I hope this much is clear. That's where I went. Something happened. Okay, that part is done. No? Okay. So that's all about your acid and bases. Now, acid and bases are of two types according to Arrhenius, strong and weak. So we'll discuss that. So substances which dissociate completely, dissociate mean to split. For example, you take HCl and the moment you add into water, it will completely split as H plus and Cl minus in water, aqueous form. At the same time, when you take CH3COH and you add into water, if suppose in a layman term, you use 1 liter of acetic acid, then initially maybe 400 ml will split, rest 600 ml remain like this. When you add more water, then some more amount will split. When you add more water, some more amount will split. So what is important? Strong acid or strong base, the moment you add into water, it 100% split, complete split or complete dissociation. Whereas weak acid and weak bases, they undergo partial dissociation. When you add more water, some more it will dissociate. When you add more water, some more it will dissociate. So the dissociation in weak acid and weak base keep on going till the time we add water to it. That is important, that you must know. So substances which dissociate completely when dissolved in water are called strong acid and the bases, whereas those dissociate partially are called weak acid and weak bases. Water itself gives H plus and OH minus. Therefore, we can tell that it can function as an acid and base, and anything which can function as both acid and base is known as amphoteric. You take water, okay, it self-dissociate as H plus and OH minus ion. So generally you cannot take a single water molecule, so they react in large number of water molecules. So what do you see? That H plus and OH minus will dissociate. This H plus will react with one of the another water molecule and form H3O plus, and OH minus will be OH minus. So this is also represented as acid. This is also represented as acid. This is known as proton. This is known as hydronium ion. Hydra means water, IM means positive, hydronium ion, and this is OH minus. So H plus you write or H3O plus you write, both are meaning same. We prefer H3O plus writing. So water act as both acid and base, so it is an amphoteric. Why it split? Question arises. The water split because of vibration which is present in the bond. So water has H single bond, oxygen single bond, H bond. It is having a bond like this. Okay. So this bond is always in vibration. Due to that vibration, the split will be there for H plus and OH minus. When you come to class, we will talk much in depth. So H plus cannot exist independently. I have told you here. So it will combine with another water molecule and form H3O plus, known as hydronium ion. So Arrhenius talks, there is an acid and base. Acid give H plus and base give OH minus. Acid is of two types, that is strong acid and there is a weak acid. So let me give you some example of strong acid. So when you take strong acid, so examples are HCl, your nitric acid, H2SO4 is a strong acid. When I give weak acid, A bar means acid. Weak acid is like acetic acid. You can take CH3COOH. You can write, you can take nitrous acid. You can take sulfurous acid. Sulfuric acid is a strong. Similarly, we can write strong base. So strong base, when you take, it is NaOH, that is your sodium hydroxide, KOH. And there will be a weak base also group. So weak base is magnesium hydroxide, Mg2 plus, so OH minus 2 times will be there. Aluminium hydroxide, this is there. Now here, one homework I am giving you. There is something known as milk of magnesia. Between this one, MgOH whole twice and AlOH whole twice. Find out which is milk of magnesia and what is the function. We will discuss when we meet in class. Okay. So acid and bases, basic concept wise we have done it, and let's now move to the salt. So acid and base, when it react, it will give salt. You can see here acid, base giving salt and water. This type of reaction is known as a neutralization reaction. One important thing what you see in salt is, suppose NaCl, then NaCl contains Cl part of an acid and Na part of a base. So salt is made up of both acid and base, one component of acid and one component of base. In HCl, Cl minus and H plus, Na plus and OH minus. So negative part of acid, that is anion, and positive part of base, that is cation, come into play. And I told you in the previous lecture about acid and basic radical, so please relate that also. Okay. For example, in H2SO4, you have 2H plus, and here you have KOH. This is mistake here. Okay, no, that's right. So you have H2SO4. So acid SO4 will come into play, and base K will come into play. So K, you know, it is plus, and sulfate, you know, it is SO4 2 minus. Crisscross you will do, you will get potassium sulfate and water. So acid negative part and bases positive part. You know what are negative and basic, negative and positive part as acid and basic radical that you refer in the previous session. So these are the few examples. Salt produce NaCl, calcium nitrate is produced, potassium sulfate is produced. They are important salts, so we'll see that. So this reaction in which acid and base react to give salt and water is known as neutralization reaction. So our salt contain both acid part and basic part. So acid part is Na plus and Cl minus. So the positive part is known as cation, negative part is anion. If you get confused, which is cation and anion, suppose if you are like me, I was a very good, very average student, then how to remember this cation? So cat, you know, cat means Billy, Billy in Hindi, or Beku in Kannada, I suppose. Basically, cat we love. Basically, we love. Some people are allergic. So cat we love, we pet it. It's one of the most famous pet than like dog and horses. And love, you know, love is a positive feeling. So cation. Okay, you feel, sir, what is this? But I relate like this. So cation is positive and anion is negative. Okay, so cation, cat is Billy, we love is positive. So cation is positive, simple. Okay, good. So the cations are called basic radical, which we have discussed already. It is positive charge and are obtained from the bases. Generally, they are the metallic ion or ammonium ion. For example, when I take NaOH, so this is Na plus and OH minus. So this is from base. So this is metallic part. Or if I take ammonium hydroxide, then plus and minus. So this is also the positive part. So cation, positive charge, it is either metallic or ammonium ion. Whereas anion is acidic radical, they are obtained from acid. So Cl minus, or you can take SO4 2 minus or NO3 minus. That part must be crystal clear in your mind that salt is made up of two components. One is cation, one is anion. Cation is basic radical, anion is acidic radical. Cation, that is basic radical, is either metal or ammonium, and acidic radical will be negative part of an acid. Got it now? Very good. So if you want me to relate, I'm relating it here. Understand this. Suppose I take KCl as salt. So this is cation, positive. This is anion, negative. Now this comes from base. Okay. So which base? Suppose I take it as KOH. And in that also, this is positive and negative part when you add into water. And this comes from acid. So which acid? So this is coming from HCl, negative and positive part. So this is base, basic radical, acid, acid radical. Connection is complete, current will flow. Okay? Good. Now, salts are classified into many types. There are many types, but for your level, I am giving you 3 types because at this time, at this point of time, you can digest this much easily. So I'm going with that. So there are many types, but these 3 types for you. Normal salt, which you can call it as a neutral also, or normal only, you keep it for your level, neutral, normal only. Acidic and basic salt. Now, what is normal salt? They do not contain any replaceable hydrogen ion. Okay. It is obtained by replacing all H plus ion in an acid by the metal ion or ammonium ion. In short, when I take Na2SO4, sodium sulfate, it is made up of 2 Na plus and it is made up of SO4 2 minus. There is no H plus and generally there will be no OH minus also. So no H plus, that's why we called it as your normal salt or simple salt also you can call. Good. Now come to acidic salt. Before I go to the definition, I will explain you here. For example, I take sodium hydrogen sulfate. The moment you add into water, the salt dissociates. Basically, salt is an ionic compound made up of cation and anion. In bonding, I will discuss that. So salts are ionic compound. Ionic compounds are formed due to transfer of electron. I will teach that in chemical bonding. There is a session on that. Don't worry on that part. So the moment you add into water, it split as Na plus, it will also split as H plus, and it will split as SO4 2 minus. You know, this is not responsible for acidic nature. This is not responsible for acidic or basic nature, but this is responsible for acidic nature. So this solution, whatever you will have, the moment you dip litmus paper, what will happen? Baap re baap or are baap re? That's right. Are baap re will take place. Acid will turn blue litmus to red. That is the meaning of acidic salt. Acidic salt means it is formed by partial neutralization. Partial means all the H plus is not removed, some is retained. Of a diprotic or polyprotic acid. Diprotic means H2SO4. Di means 2 and protic means proton, 2 proton, or polyprotic means H3PO4, like that. There is more than 2 H plus ion in it. Is known as acidic salt. This salt have ionizable hydrogen ion, what I have shown you here, with another cation. Cation is sodium. Mostly the ionizable H plus part, mostly the ionizable H plus is the part of the anion, means it is the part of HSO4 minus. That is the meaning of the last statement. In simple word, acidic salt is produced due to partial neutralization, and it contains H plus in it with another cation, and this H plus is the part of anion. Simple. Okay. Acidic salt is made due to partial neutralization. You take acid, you take base. The acid must be diprotic or polyprotic. It will have 2 H plus or more than 2. 1 or 2 or 3 H plus will be not neutralized. It will be the part of salt. The moment you add into water, there will be one cation with that H plus, and that H plus is the part of the negative anion. That's it. Okay? Good. Coming to the basic salt is exactly opposite of your acidic. Name only you can predict. For example, if I take copper hydroxide and this is nitrate part. So the moment you add into water, it will split as Cu2 plus and OH minus and NO3 minus. Overall, the salt is neutral, 2 positive and 2 negative. But there are 2 negative ions which is present here. Due to this, basic solution you will get. If suppose you add into water, you will get basic solution. Basic solution, how to detect? You will add litmus paper. What will happen? Baap re baap or are baap re? Baap re baap. Basic re baap, red to blue. Okay. So it is formed by partial neutralization of a strong acid by a weak acid. Strong base by a weak acid. So you take a strong acid like NaOH or any strong base and treat with a weak acid like acetic acid or sulfurous acid, nitrous acid. So these salt have ionizable OH minus ion. Ionizable means they can form ion along with another ion. So there is OH minus ion and another ion. So example is these two, ZnO, HCl and CuOH, NO3. Now why I have written this into bracket? You can write like this or you can avoid. When you come to us, we will tell you. Since chlorine is a single atom and these all are molecules, dimolecules, and it is polymolecular, that's why we write into bracket. Bracket as such is just for separation. Okay? That's all about acid, bases and salt, and we have discussed it. So let me just take a sip of water, then we'll start. Okay. So till now we have discussed acid, we have discussed bases, we have discussed salt, type of salt, and etc. Now, one important question, what comes in our mind? The question is that, what happened again? Okay. The question is that, if suppose I have a beaker, suppose I have 3 beaker or I have 3 test tubes. And suppose in this I keep it as HCl. Suppose I keep in it as nitric acid. And suppose I keep it in this as acetic acid, which is in vinegar. And I ask you to find out how you will find out. Or same thing I do with base. I keep 3 beaker and 3 different base. They all are colorless solution. You cannot see and tell, okay, and HCl will not call, hi, I am HCl. Not possible. You cannot see and tell which is HCl because all are like water. It is colorless. Just like this bottle inside water is there now. Just like that it will be there. How to find out? One thing. For that, you cannot taste it because HCl is corrosive. Acetic acid you can taste, so you have to avoid it. You cannot touch it because the skin will get burned. How to find out? So we need something known as indicator. Okay. And pH, in pH, that too litmus is an indicator what we use. Methyl orange, Congo red and all, they all are indicators. So, and one more thing, if suppose I dip litmus paper here, I dip litmus paper here and I dip litmus paper here, you know that acid, that is, it will turn blue to red. All will become red. How to find out which is a strong acid, which is a weak acid? Here acetic acid is weak. HCl and HNO3 is strong. The color will be same. They will give red color. How to find out? So in order to differentiate between the acid strength, strong or weak, we need a scale, mathematical scale, that is known as pH scale. To differentiate strong acid, strong base, weak base, which we cannot do using litmus paper because color cannot tell you whether it is strong or weak. It will just tell if it is an acid or base. We need a scale that is pH scale. That is the significance of pH. So we often hear that certain substances are acidic or basic in nature. But how does one find out that the substance is acidic, basic, or neutral? You use pH, litmus, strip. What makes the substance acidic and basic, H plus and OH minus? All these things are determined with the pH scale. So pH scale basically, Arrhenius tells acid and base. pH help us to find out what is the strength of acid, what is the strength of base, whether it is highly strong acid, or it is a weak acid, or it is a moderate acid, strong base, weak base, or moderate base. That is the function of pH scale. So pH is a numeric scale. Numeric means it has value in chemistry that is used to find out whether a substance or a solution is acidic, basic, or neutral in nature. This concept of pH, now pH you have to write like this, okay? Now what is the meaning of pH? pH stands for potential of hydrogen. Basically potential of hydrogen ion. Potential means what? Power. If suppose I have two beaker, in one beaker I have 10 H plus ion, layman explanation. Another beaker I have 100 H plus ion. Which has more power? This one. Which is the stronger acid? This one. Which is the weaker acid? This one. So pH stands for power of hydrogen, and you have to write pH like this. Don't write pH like this and all. So P as a subscript and H as a superscript, both in caps generally we write. Okay. So this concept was developed by Mr. Sorensen. He's a Danish chemist in Carlsberg laboratory in the year 1909. And later it is updated and revised in 1924. So this is your pH scale. So pH scale starts from 0 and it goes to 14. You can tell from 0.0 to 14.0. That is specific more. The seventh, that is 7.0, it is neutral. That is your pure water or distilled water. 0 to 6.9. Or for your level 0 to 7, it is acidic. And 7 is your neutral. And 7 onwards to 14 is your basic. So basically 0.0 to 6.9 is acidic, 7.0 is neutral, 7.1 to 14.0 is basic in nature. So you see the different color intensity. So 0 means highly acidic, 14 means highly basic. Here 6 to 7 means weak acidic. Okay, your blood falls in that region, okay? 6 to, that means it will be around 7 to 7.5 wala region. Here it is moderate basic. Okay? Milk and all, they fall basically in this area. That you will find out later. Got it? Any doubts? Potent is the German word which means power. Now here, there are various day-to-day molecules or substances which we interact and their pH where they lie. The battery, you know, the big battery when which is used in the truck and the vehicles or inverter. So this is highly acidic. Then stomach acid, that is HCl. It is 1. It is also highly acidic. Then lemon is there. This is vinegar. Tomato, it is having oxalic acid. Then coffee. Coffee is acidic, my dear friend. You need to find out black coffee, what is the acidic strength. Then milk. Milk is slight acidic. Then you have pure water. This is pure water, not tap water. Tap water is not neutral. Then you have blood between 7 to 7.5 range. It is not 8. This is just a reference, okay? Then you have baking soda. Then stomach tablet, that is antacid, eno and all, gelocil and all what you eat. Then ammonium solution, it is a strong base, soap, bleach, drain killer, highly basic in nature. So acidic, neutral, alkaline. What is alkaline? A base soluble in water is known as alkaline basically. What the point? Okay, now pH, if suppose I give you 3 pH value. There is pH 3. Suppose I take pH 8 and I take pH 13. And I ask in which of these three the H plus ion concentration will be more. Concentration means what? Amount. So H plus ion amount will be more in this. H plus ion amount will be less in this. And H plus ion amount will be intermediate between these two. Then I ask in these three, in which case OH minus ion concentration is more. Then OH minus ion concentration is high here. OH minus ion concentration is lower here, and OH minus ion concentration is in between these two. Okay, you get a lot of problem numericals in this when you come to us in the first chapter of in physical chemistry equilibrium chapter. We will deal with this in detail. Then you will realize the importance of pH. This was just a basic idea which I have given you. Now, pH, why it is important for us, I told you. Now, how it affects our day-to-day life, you understand. Few example I am giving you. For example, 2 years back on the same date, that is 2nd of July, I got a severe toothache. So I had an infection in my gum. So I had to undergo RCT, that is root canal treatment. Then my dentist, he explained that Adil, what happened is we get pain due to many reasons, but 2 reasons are there. One is infection and one is cavity. So if your mouth pH value falls less than 5.5, then cavity will form. Why it is so? We eat many things. We eat chocolate, we eat dosa, idli, sambar, biryani, curd rice, puliyogre, sweet pongal. They will go and stuck in between your teeth. And if you don't clean it properly, the organism, bacteria and all what is there, they will break it and they produce acid, and that decreases the pH of the mouth. And that's why the cavity takes place. So this is important in our day-to-day life. Simultaneously, when you talk about our blood pH ranges vary from 7.2 to 7.8. It again depends which country you belong, which type of soil you live, which type of food you eat. Okay, so 7.8 is acidic and 7.2 is close to your neutral wala part. We eat so many things. For example, you see, we eat pickles. We eat jams. We eat, suppose anyone who is non-vegetarian, they eat non-veg food, which is basically acidic in nature. But the blood pH is maintained. It's not like that you drink 2 liters of HCl, nothing will happen. Then you are gone. Little amount of acid goes in your body. Suppose you eat 5 lemon in a day, you get acidity, but the blood pH remains same. If the pH of the blood changes, you will feel pain, cramp, and excessive amount, which leads to gout, which is uric acid, and it leads to death also. So pH of the blood is maintained by a chemical known as buffer, which we will do next. So pH is important to maintain our metabolic and day-to-day life. Let's talk about soil, the great farmers, because of whom we are surviving. So the pH of the soil is between 5.5 to 7 basically. Now you would have heard about acidic rain, the rain which causes the marble of the great Taj Mahal lose its color. If acid rain fall on soil, the soil become acidic. And few crops, they cannot grow on that. So it will affect the crop production. So acidic and pH is required to check the soil also. Same thing goes with aquatic organism and all. So you just remember that pH is very important for us, for soil, for microorganisms, for macroorganisms, etc. pH basically helps to measure the strength of acid and base, and that's it. So I hope you have understood this. So that's all from today's lecture. So I have discussed acid, bases, and salt, whatever was required, the significance of pH, and few important molecules or compounds here, substances with their range of pH value. Exact value is not there. So these are the 5 questions of the day. So name the acid present in honeybee that you need to find out, and I'll discuss tomorrow. the pH value of the blood, exact value you have to give. Don't give me a range. I'm talking about Indians, and Indians also you have to give me with vegetarian. Means Indians. State the difference between lime water and lime juice. Don't think it is same, it is different. A student detected the pH of 4 unknown solution ABCD. Predict the nature of the solution. Let me know tomorrow. And name 2 indicator which is widely used in a laboratory. So in between my lecture, I have given you answer of all of these, either written on the board or orally. So you give me the answer. Before leaving for the day, all of us at some point of time, wasp or honey bee would have stinged us or attacked us in our village area, basically. So when wasp attack us, it is suggested to apply vinegar. Just for knowledge, I'm telling. And when bee attack us, it is suggested to add treat with baking soda, apply baking soda. Vinegar is acid, baking soda is base, but they both are belonging to same type of family, you can tell. Basically on the range you could just say. Why so? The reason for that Mr. Wasp, it secrete a basic solution, a basic chemical which goes inside our body or skin and irritate us. Same thing with bee. I have given you homework, honey bee what. So the chemical what this releases inside or on our skin when it comes and attacks us is basically an acidic chemical. That's why you use a basic thing to neutralize it. And wasp releases basic chemical. That's why vinegar is used as acid to neutralize us. So you will find out for these two also. And one more thing. We eat a lot of pizza and we use tomato ketchup. Okay. Tomato ketchup or tomato, whatever you call in your term, tomato ketchup or chutney, whatever you call, it has many type of acid in it. One of it is oxalic. Another important acid is what? Find out when we start the classes. I will ask you all this. I have noted this down. So for tomorrow, this much is the homework. So do it. And I hope acid, basis, salt, and pH will be clear to you here onwards. So that's all from my side. So take care of yourself, respect your parents, respect animals, and bye-bye. Take care, guys. God bless you all.